Okay, Assalamualaikum dan salam sejahtera. InsyaAllah hari ini kita akan sambung chapter crystal field theory. Okay, sebelum ni minggu lepas kita dah cover kenapa crystal field theory ni. So nak complement valence bond theory, VBT. And then kita juga belajar tentang ligand, tentang how ligand approaching metal. So electron negatively charged ligand dengan positively charged metal center, so ada electrostatic attraction dan juga repulsion between the d orbital dengan ligands. So ada 5 type of d orbitals, ds square minus y square dz square. This is 2 higher in energy, 4 octahedral, and then 3 other type of d orbitals, xy, xz dengan yz. Okay, kita belajar juga tentang color, and then complementary color, absorb, and then observe color. Spectrochemical series, so we have weak ligand, halide for example, and strong field ligand, ammonia, amine, ethylene diamine, cyanide. Okay, and how this ligand affects the splitting energy increases. So this is small splitting energy, this is large splitting energy. Okay, jadi for today's lesson, we will learn about ligand field strength. Okay, so we have seen previously, so this is the spectrochemical series. So how the ligands are arranged in terms of their tendency, whether weak field ligand or strong field ligand. So now we're gonna look actually how the ligand field strength, the characteristic. Okay, so as we seen previously, so d orbital of metal is no longer degenerate. Okay, so degenerate means previously it was probably it was 5 degenerate like this, but now is no longer degenerate. So for example, for octahedral, split into these 2 levels. So higher energy, low energy. So going back to the slide. So when we fill in electrons in the orbital, we must fulfill or we must follow Hund's rule. Okay, so we fill in electron in lower energy first and then to higher energy. Okay, so here we have one term called splitting energy. So the energy different. So this is splitting energy between low level to high level. So this is splitting energy. So this is splitting energy. And then another term is energy pair. Okay, so this is energy pair. So we always occupy the lowest energy first, and then this is and then we pair up another level. So for example, the energy pair. So let's say we start filling electron. Okay, so we fill in 1, 2, 3, And then now depending on the splitting energy, so if we have high energy, so the electron can be put there, or otherwise we need to put energy electrons if this is too large. So if the splitting energy is too large, so not able for the electron to be filled in high energy, so instead what happened, the electron will be filled in at the bottom energy. Okay, here. So kebiasaannya kita akan fill in energy daripada bawah, okay, dan ke atas. So satu, kita isi satu elektron, satu elektron, satu elektron, satu elektron, satu elektron. But sometimes because the splitting energy is too high, is too big, so we have to fill in electron next to the pre-existed electrons. Okay, instead of kita fill in satu-satu, kita kena isi dekat pair. So this is called electron pair. So going back to the slide. Okay, so this is called electron pairing energy. So the energy required to pair the electron. So the electron can be singly occupied or it can be paired. Okay, so this one is singly, it's a single electron. This is pair. So this is electron pair. So this is electron pair. This is this is energy for electron pairing energy. Okay, so if the splitting energy is higher than electron pair, so the electrons tend to form pairing in the orbital. We call it low spin. However, if okay, so now let's take a look about low spin and high spin. Okay, so if the splitting energy, okay, for example, we draw like this. Okay, so we have, so the energy difference between the level. So the energy difference so this we call as splitting energy. Okay, splitting energy. Okay, when we fill in electron, so we put the electron. Okay, so depending on the so if the splitting energy is higher than energy pair, so the electrons tend to form pairing in the orbital for low spin. Okay. So if this splitting energy, if D is bigger than energy pairing, so this means that the electron will be free in low spin. Okay, for example, we have another electron, so this is low spin. Okay, low spin. However, in other cases, if the energy of the splitting is less than electron pair, so this will form high spin. Okay, so because here the enthalpy is or the splitting energy is smaller than electron pair, so it will be high spin. So if the splitting energy is small than electron pair, So the extra electron will now go to this at higher level. So this is we call as high spin. Okay, so we have high spin, low spin. So high spin, if the splitting energy is lower than an electron pair energy, and for low spin, where all the electrons in lower level, the splitting energy is higher than electron pair. So now we look back at the spectrochemical series. So this is the spectrochemical series. So ligands at early spectrochemical series, for example, halide. So early spectrochemical series, for example, halide. So they exhibit high spin configuration. So what does it mean by high spin configuration? So high spin is, so this is high spin. Okay, so this is high spin. So high spin means low or small splitting energy. Small splitting energy. So this is known as weak ligand. And in opposite, so ligand on the other side of spectrochemical series on the right. So this is strong field, so they will adopt low spin. So for strong ligand, they will adopt low spin. So this is low spin, okay? So if I can add, so high spin for weak ligand, for example, halide, and for this is strong field ligand, for example, cyanide, ammonia, okay? So it's strong field ligand, and weak field ligand, okay? So we have to. So we have ligands located in between. So this is intermediate ligand, middle field ligand. So we have, so this is, so those in blue is weak ligand. Those in greens are intermediate ligand, and those ligand in red are strong field ligand.